Good afternoon, students. Welcome back once again to the mathematics class. So, in this session, we are going to study some more problems based on homogeneous differential equations, right? So, in today's lecture, we conclude this homogeneous differential equation. So, from tomorrow onwards, we will start our new concept that is nothing but linear differential equation. So, before that, examples on homogeneous differential equation, right? So, the first example of our today's session is solve the differential equation. This first example, solve the differential equation x cos y by x plus y sin y by x close bracket into y dx, which is equals to y sin of y by x minus x cos y by x into x dy, right? This is nothing but our differential equation. Here we have to solve this one with respect to homogeneous differential equation, right? Solution first. Solution, we have, write down once again, x cos y by x plus y sin y by x into y dx, which is equals to y sin y by x minus x cos y by x into x dy, right? So now initially we have to convert this into the standard form, that is nothing but x by y or x dy as it is. When we take this term on RHS, it becomes y dx, just reshuffling here, so remaining as it is. To convert it in the standard form, that is dy by dx equals to g of x upon phi of x, right? X cos of y by x plus y sin y by x divided by y sin y by x minus x cos y by x, right? So now again, which implies dy by dx, which is equals to y take on the numerator from RHS side and x also in the denominator of RHS. So it becomes y x cos y by x plus y sin y by x. The denominator x into y sin y by x plus of, sorry, minus it is, right? Y sin y by x minus x cos y by x, close the bracket, right? So now it is in the standard form. Take it as equation 1 here now. Consider this as equation 1. So now put y equals to vx, y equals to vx, so that so that dy by dx is nothing but, again u into v formula already we know, v plus of x dv by dx. In equation 1 we get, so just substitute the values, v plus of x dv by dx, which is equals to, value of y is here vx, right? Vx inside the bracket x cos v, because v means y of x here, so again y is there, vx sine v, right, whole divided by x vx sine v minus x cos v, right? So now, which is equals to, v as it is, take x common from these two terms from the numerator, what we get already, x is there outside, so again one more x means it becomes x square, inside what we get here, cos v plus of v sin v, it is, right? V into sin v. In the denominator also take x common, already x is there, it becomes x square, inside the bracket v sin v minus of cos v, which is equals to x dv by dx, which is equals to, here x square get cancelled from numerator and denominator. In the numerator remaining, write down cos v plus v sin v, denominator v sin v minus cos v. This plus v term from LHS we have taken here, so it becomes minus of v, right? Now cross multiply here, what we get, let's see, which is equals to v cos v plus, multiplying this v inside, v cos v plus v square sin v minus of, cross multiply this, what we get, pv v square sin v minus minus plus v cos v, right? Whole denominator, it is whole divided by v sin v minus of cos v, right? So now here plus sine square minus sine square we get cancelled, which is equals to v cos v, it becomes 2 times of v cos v. In the denominator v sin v minus cos v, right? So now variable separable here in the LHS, x dv by dx is there, so now variable separable, what we get here, v sin v minus of cos v divided by v cos v dv, right? 2v written here only, so 2 here only as it is dx upon x, right? Now again we can convert, if we write the numerator and denominator separately, what we get, v sin v upon v cos v minus of cos v upon v cos v, which is equals to dv is 2 times of dx upon x, right? We are taking denominator separately here. Now v get cancelled from both the term, here v get cancelled, here cos v get cancelled, the remaining term is tan v sin v by cos v is tan v minus 1 by v dv, which is equals to 2 times of dx upon x, right? So now integrate, which implies integration of tan v minus 1 by v dv, which is equals to 2 times of dx upon x, right? So which is equals to integration of tan v is log of sec v minus 1 by v is log v, which is equals to 2 times of log x plus log c, right? So now, which can be written as in the LHS, log m minus log n can be written as log m by n, right? That is sec v by v, which is equals to log of 2 is there. I can take here x square, right? Log x square plus of log c is there. So again, which implies log sec v upon v, which is equals to what we can write here, log of cx square. Log m plus n can be written as log mn, right? So now log get cancelled from the both the side. What we get here, sec v upon v, which is equals to cx square, or you can take it here, c1 you can take here, log c1 it is, right? Log c1 of x, right? It is c1 of x. Now substitute the value of v here, right? Put value of v, what we get here, y value is simply v value we can write y by x, right? V equals to y by x or y equals to vx, right? So we are getting here x upon y, simply y is there no here, so just sec v means sec of v value is y by x, in the denominator it is y by x, it is c1 of x square, right? So now this term goes in the numerator, means what we get here, it becomes x by y into sec y by x can be written as 1 upon cos y by x, right? Reciprocal of sec, which is equals to c1 x square. So now we can write, take x square to the LHS, it becomes what, x upon, already y is there, so x square y cos y by x, which is equals to c1, right? So here x get cancelled, remaining what we get here, 1 upon xy cos of y by x, which is equals to c1 is the right. So this term take to a RHS, what we get when it becomes 1 by c1, which is equals to xy cos of y by x, right? So now 1 by c1 can be written as c, so finally we can write it as xy cos of y by x, which is equals to c, because 1 by c1 is what we are taking here, c, though hence it is nothing but our final solution of differential equation 1, right? It is a required solution. Similarly, we will see next example. It is example 2. Example 2. Solve the differential equation solve the differential equation x dy minus y dx, which is equals to under root of x square plus y square into dx, right? So solution, we have x dy minus y dx, which is equals to under root of x square plus y square dx, right? So to convert it in the standard form, so you have to convert it, which implies x dy, which is equals to under root of x square plus y square dx plus y dx. If we take here dx common, then we can write it as dy by dx, which is equals to under root of x square plus y square plus of y whole divided by x, where x is not equals to 0. Take it as equation 1, right? So now it is in the standard form and it is a homogeneous differential equation. So now put y equals to vx, and dy by dx, which is equals to v plus x dv by dx in 1, right? Then we get v plus of x dv by dx, which is equals to under root of x square plus v square x square, because y value is vx, x plus of vx, again y is right. So now v plus of x dv by dx, which is equals to, by taking x common here, what we get inside 1 plus of v square plus of v upon x, so x get cancelled here, so remaining write down as it is, which implies v plus of x dv by dx, which is equals to 1 plus of v square plus of v, right? So now take v RHS, dv upon dx, it becomes 1 plus of v square plus v is there, minus v means plus v minus v get cancelled. So finally what we get, 1 plus of v square, right? So now variable separable, so which is nothing but dv upon the root of 1 plus x square, which is equals to dx upon x, right? So now integrating on both sides, we get is integration of dv upon under root of 1 plus of v square, which is equals to dx upon x, right? So now which is in the nothing but 1 upon under root of a square plus of x square form to dx. So what we can do here, integration of this is log of x plus under root of x square plus a square, or a square plus of x square plus of c, right? So now we can get here log of v plus under root of 1 plus v square. Here 1 means a, 1 square is nothing but 1 only, a square plus x square, that is nothing but 1 square plus v square is again 1 plus v square. So which is equals to log x plus of log c, right? So now from the both the side, if we cancel the log, then we get mod v plus 1 plus of v square, which is equals to mod cx, right? So again, now substitute value of v, what we get here, that is y by x plus under root of 1 plus y square by x square, which is equals to cx. So what we can do here again, which implies y upon x plus Cross multiply, what we get here? X square plus y square upon x square, right? Which is equals to cx. So now, which implies y by x plus, if we take x outside, what we get? 1 upon x inside x square plus of y square into cx, right? So squaring on both sides now. Squaring on both sides. So what we get here after squaring? This term goes in the numerator, y plus under root of x square plus y square whole square. We are taking the denominator x this term to the RHS, so it becomes already squaring on both sides means already it is x square is there. So again here also these two x square we are getting here. So what we get here finally? C square x to the power of 4, right? Which is nothing but our required solution. Squaring on both sides, then simply y plus under root of x square plus y square whole square we kept in LHS. The denominator term squaring, the denominator term becomes already x square. So commonly x square goes to the RHS, it becomes already x square is there. X square into x square is x to the power of 4, hence it is nothing but our required solution. So the next example is that is third example. Example 3. Solve y dx plus of x log y by x dy minus 2x dy, which is equals to 0, right? Solution, we have y dx plus x log of y by x into dy minus 2x dy equals to 0, right? So now convert it in the standard form. What we get here? Dy by dx equals to y upon x divided by 2 minus log of y by x, right? So take it as equation 1. Take it as equation 1. So now equation 1 is homogeneous differential equation. Put y equals to v of x. Put y equals to v of x, so that dy by dx is nothing but here v plus x dy by dx in 1 we get. So now v, after substituting v x dv by dx, that is LHS, dy by dx value is v x dv by dx, which is equals to y by x is nothing but v, it is 2 minus log v, right? So x dv upon dx, which is equals to v upon 2 minus log v minus of v. So after cross multiplying, what we get, which is equals to v minus of 2v plus v log v upon 2 minus log v, right? So x dv by dx, which is equals to minus v plus v log v whole divided by 2 minus log v. So separating variables here, separating variables v and x, we get, so 2 minus log v divided by minus v plus v log v into dv, which is equals to dx upon x. So again, which implies we can write 2 minus log v in this form. It is 1 minus log v minus 1. Again, it is in the similar to numerator. So by taking v common here, we can write log v minus 1 in positive term into dv. So dx upon x as it is, right? So next, now separate the denominator here. What we get, let's see. Separating the denominator, so which implies 1 upon v log v minus of 1 minus 1 by v dv dx upon x, right? So again, integrating here, integrating on both sides, we get integration of dv upon v log v minus 1 minus integration of dv upon v, which is equals to dx upon x, right? Take it as equation 2. So now let us consider I equals to the first term, that is dv upon v log v minus 1, right? So put here log v minus 1 equals to t. Log v minus 1 equals to t, which implies 1 by v dv equals to dt, right? So I becomes I equals to dt by t, right? So which is equals to log t. So again, which is equals to log of value of t is log v minus of 1, right? So now from equation 2, we have, it is log of log v minus 1 log v minus 1 minus of 1 by v is log v, which is equals to log x dx upon x is log x plus of log c. Take it as equation 3, right? So now put the value of v in 3. Put value of v in equation 3, then we get log of log 1 by x minus 1 minus log y by x, which is equals to log x plus log c. So again, which implies log of log y by x minus 1 minus of log y plus log x. Log m by n can be written as log m plus n, right? So which is equals to log x plus log c. So finally, what we can write here, which implies log of log y by x minus 1, which is equals to log y plus log c, because log x get cancelled from LHS and RHS. So again, which is equals to log cy. So finally, by cancelling log of y by x minus 1 which is equals to cy. Log y, log get cancelled from both the terms. So log y by x minus 1 which is equals to cy. So which is nothing but our required equation, right? So with this we conclude our today's lecture. The next lecture we will see some more example with different concepts, right? So till then, take care, stay at home, stay safe. Thank you.